Hi guys, so today's leetcode problem. We'll be looking at the valid stack sequence medium difficulty problem. Okay, so given two integers pushed and pop, each with each distinct value. Okay, turn true if this could have been the result of a sequence of push and pop operations on an initial empty stack, or false otherwise. So they came and gave us an example: pushed and pop. This would return true. Explanation: we might do the following sequence: push 1, push 2, push 3, push 4, pop 4, push 5. Okay, so we already popped 4. Then hence we went ahead to pop 5, pop 3, pop 2, pop 1. So this would return true. Okay. And we are given example 2. Imagine we had an empty stack. A stack is a data structure that uses the LIFO principle, last in, first out. So we push 1 into that stack, we push 2, push 3, push 4, push 5. So we wanted to do a pop sequence. We'll pop 5. Or let's say we pop 4 before. Yeah, if you said we pop 4, then we push 5. Yeah, this array would return false. Okay, because there's no way we could have gotten 4, 3, 5. Because if we had done this method, even if we had popped 3, then we push 4, we push 5. 3 should be the first number. Like it should be here at 0 index of this array. So the constraints: push dot length, the number of values in our output array is 100. We can get numbers within the range of 0 to 100. All elements of pushed are unique, and the popped and the pushed array would always have the same amount of number. Popped is a permutation of pushed. Okay, in order to solve this, we'd simulate what the question asks us to do. We'd create an empty stack. So let's stack. Alright. And then we would look through this pushed. For, let's see, for elements of pushed, we add them to a stack. Stack dot push and dot push elements. Okay. Then we want to compare if the last element in the stack is equal to the first element in this popped. Yeah. I write a while loop to check if stack is empty. Stack dot length greater than 0, and we want to check if the last element of the stack, because we are pushing, is equal to the first element in this pop. Okay. We need a counter. Let's count, because we need to keep track of the elements we have been through in the pop. So we create that to 0 because it would first be 0. So we do the check. stack dot length -1. That is the last element in the stack. Right. Is equal to popped, and we use the counts. That's the first element, because count is 0 right now. If this is true, then we do stack dot pop. Remove an element from the stack, because they are equal, and we increment our counts. Okay. At the ending of this would loop through. Okay, let's take this example of this code. This would loop through pushed, so it would go 1, 2, 3. This push 1, checks if the stack is empty, no, and it checks if the last element is equal to the first element. So it checks if 4 is equal to 1. This will return false. Then it would loop through 2, checks if 2 is equal to 5. It's false. It will loop through 3, check if 3 is equal to 3. That's true. It pops 3 from the empty stack. So let's say loop through 1, it adds 1 to the stack, but it does not increment the count. Loop through 2, it adds 2 to the stack, but does not increment the count because we still have 4. Loop through 3, adds 3 to the stack, but it still does not increment the stack because popped dot count, that is, it still has 4. Loop through 4, then it increments the count because 4 is equal to the first value here. So it increments the count and pops this from the array. Then loops through 5, adds 5 to the array. Then checks if, because the count has increased now, so count is now 1, and this is the position for 1 index. Checks if 5 is equal to the last element, increments the count. So this while loop would run and go backwards, so 3, 2, 1. And by the time it checks that, pops everything from its stack would be 0, like the length would be 0, and then the while loop will stop running, and count could have increased to the length of the pushed array. So at the ending of this, we want to check if return count is equal to pushed. Basically, pushed and given that pushed and popped are the same length, you can actually also use pop here because it's part of the constraints we are given. And this should be the answer to the problem. It's taking its time. Yeah. This should be it. I would increase the speed. My stack dot this would create a while loop. My stack isn't empty, so forgot that. This would create stack dot length is never going to be empty. It's never going to be 0. So at the ending of this function, because of the stack dot length is never going to be 0, right? This while loop, this should have broken the while loop if I'm not mistaken, unless there's a test case in which we have, but the constraint didn't allow us to do that. So this loop would most likely run for a very long time. Let me reload the page. Okay, so it passed. Yes. So that's the solution to the valid stack sequence problem.